Hello everyone, my name is Akash Patel and welcome to my presentation on Model Evaluation Fundamental. So this presentation is a part of my AWS Certified Machine Learning Engineering learning journey. In our previous discussion, we learned how machine learning models are trained using historical information. However, training is only one part of the machine learning process. After a model finishes training, organizations still need to answer an important question. How do we know whether the model is actually performing well? A model may appear successful during training, but that does not automatically mean that it will perform well in real world situation. So this is where model evaluation become important. So in this presentation, we will explore how organization measure machine learning performance, why evaluation is necessary, and how different evaluation methods help improve prediction quality. So let's begin. So before we start, we discuss specific evaluation methods. Let's first understand why model evaluation is needed. So imagine spending weeks or even months developing and training a machine learning model. A model appear to be working correctly and training has been completed successfully. Now imagine deploying that model directly into business environment without testing it. So this could be risky because the model may still make mistake and affect customers, employer, or business operations. Organizations need confidence that their machine learning systems can make reliable prediction before those systems are used in the real world. So that is exactly why model evaluation exists. So in this presentation, we will learn that model evaluation means why it is necessary after training and how organization measure prediction quality. So we will also explore important evaluation metrics such as accuracy, precision, and recall using practical examples that are easy to understand. In addition, we will examine several real-world business applications and learn how evaluation help improve machine learning systems before deployment. By the end of this presentation, you will have better understanding of how organization determine whether a machine learning model is ready for real world use. So let's move to the next slides. So now let's discuss what model evaluation actually means. So model evaluation is the process of testing a machine learning model after training has been completed. The purpose is to determine how well the model performs when making predictions. So many people think evaluation simply check whether the model works or not. However, evaluation is much more detailed than that. Organizations want to know how accurate the predictions are, how consistent the model is, and whether it can perform well when working with information it has never seen before. To accomplish this, the model is tested using new information that was not included during training. This is important because it helps determine whether the model truly learned useful patterns or simply memorized the example it saw earlier. Think about the student preparing for an exam. Memorizing practice questions may not help during practice sessions, but the real test comes when new questions appear on the exam. Machine learning evaluation work in a similar way. The goal is to determine whether the model can apply what is learned to new situation. Without evaluation, organization would have no reliable way to know whether the machine learning model is ready for deployment. So for this reason, evaluation act as a quality check before machine learning systems are trusted to support important decisions. Let's move to the next slides. So now let's look at why organizations spend so much time evaluating machine learning models. So today, machine learning is used in many industries. Retail companies use machine learning to recommend products. Hospitals use machine learning to help identify health risks. Bank use machine learning to monitor transactions and detect suspicious activity. In all of these situations, prediction quality is extremely important. Imagine a recommendation system suggestion completely irrelevant products. Customers would likely ignore the recommendation. Imagine a healthcare systems failing to identify a pattern who required medical attention. The consequences could be much more serious. Similarly, if fraud detection systems misses suspicious transactions, financial losses may occur. These examples show why organizations cannot simply assume that a model is performing correctly. Evaluation help identify weakness before those weaknesses affect real users. By measuring performance early, organization can make improvement, reduce risk, and increase confidence in the systems. In short, model evaluation help ensure that machine learning solutions provide value while minimizing potential problems. Let's move to the next slide. So let's start with one of the most common evaluation metrics in machine learning, which is accuracy. Why, when organizations first evaluate a machine learning model, accuracy is often one of the first measurement they examine. Accuracy simply tell us how often a model makes correct predictions compared to the total number of predictions it makes. In other words, it provides an overall picture of how well the model is performing. Let's use the example shown on the slide. Imagine a school create a machine learning systems to predict whether student will pass an certified exam. The model reviews information about students and predicts whether each student is likely to pass or fail. After the exam takes place, the school compares the model's predictions with the actual results. Suppose the model correctly predicts the outcome for 90 students out of 100. This means the model achieved 90% accuracy. At first glance, this sounds so impressive because most predictions were correct. That is why accuracy is often used as a quick way to understand overall model performance. However, as we will see in the next slide, accuracy does not always tell the complete story. Sometimes a model can have very high accuracy while still making important mistakes. Let's move to the next slide. So, many people assume that if a model has high accuracy, that it must be a good model. However, this is not always true. Look at the fraud detection example shown on the slide. Imagine a bank process 100 credit cards transactions. Out of those transactions, only 100 are actual fraudulent. The remaining 9,900 transactions are legitimate purchases made by customers. Now imagine the machine learning models predicts that every transaction is normal. It does not identify a single fraud case. At first, this sounds like a terrible model. And let's calculate the accuracy. Because 9,900 transactions were actually normal, the model correctly classified 9,900 transactions. As a result, the model achieved 99% accuracy. This create a problem. The accuracy looked excellent, but the model completely failed at its most important job, which was identifying fraud. The bank would still lose money because fraudulent transactions were not detected. These examples teaches an important lesson. Accuracy provide useful information, but organization often need additional evaluation metrics to understand how well a model is truly performing. That is why metrics such as precision and recall are also important. Let's move to the next slide. Now let's discuss precision. Precision focus on the quality of positive predictions. In simple terms, precision asks the following questions. When the model says sometime something is positive, how often is it actually correct? Let's use the email spam example from the slide. Every day, email providers process thousands or even millions of messages. Some messages are legitimate email from co-workers, customers, teachers, or family member. Other messages are spam that users does not want to receive. The machine learning models reviewing incoming emails and predict which message should be placed in the spam folder. Now imagine the model marks 100 emails as spam. After checking the result, we discovered that 95 of those emails were truly spam, while 5 are actually important message. This would indicate high precision because most of the spam predictions are correct. Why is this important? Because users do not want important emails incorrectly sent to the spam folder. Imagine missing an email about a job interview, an important business meeting, or a university assignment because the systems incorrectly marked it as a spam. So precision help organization measures how trustworthy positive predictions are. Higher precision means users can have greater confidence in the system's decision. Now let's do the more. Okay, now let's move on the recall. Recall focus on finding as many important positive cases as possible, while uh, precision asks whether positive predictions are correct. Recall asks the different questions out of all the actual positive cases. How many did the model successfully find? Let's use the healthcare example. Imagine a hospital uses machine learning to help identify patients who may have a serious illness. The systems review patients' information and attempt to identify individuals who may require additional medical attention. Suppose 100 patients actually have a disease. If the model successfully identify 95 of those patients, the recall is very high because most positive cases were found. Why does this matter? Because missing a patient who actually has a serious illness could delay treatment and create health risks. In healthcare, finding affect patients is often more important than achieving perfect precision. Doctor would generally prefer to investigate a few extra patients rather than overlook someone who truly needs care. That is why recall is especially important in medical applications. High recall help healthcare organizations reduce the risk of missing patients who require treatment and support. As we continue through this presentation, we will see the different industries prioritize different evaluation metrics depend on their goals and risks. Let's move to the next slide. Now that we understand accuracy, precision, and recall, an important question comes up. Which metrics should organization use? The answer is that there is no single evaluation metrics that works best for every machine learning project. Different projects have different goals, risk, and business requirements. Because of this, organizational choose evaluation metric based on the problem they were trying to solve. Look at the example. First, considered email spam detection. User want unwanted spam messages filtered out, but they also want important email delivered correctly. If an important email is incorrectly placed in the spam folder, users may miss valuable information. In this situation, precisions become very important because organization want the systems to be highly accurate and when it labels as an email as spam. Now let's consider disease detection. Hospitals want to identify as many patients with disease as possible. Missing a patient who actually have a serious illness could delay treatment and create health risk. Because of this, recall become extremely important. Healthcare organizations would rather investigate a few extra patients than miss someone who truly need medical care. Now think about online shopping recommendation. Businesses want customer to receive useful product suggestions that match their interest. In this situation, multiple evaluation methods may be used together because organizations want recommendation to be both accurate and helpful. The key lesson is that evaluation metrics are tools. Organizations choose the right tools based on their goals and potential consequences of mistakes. Let's move to the next slides. So now look at the complete real world example that combine many of the concepts we have discussed so far. Imagine a bank process millions of credit card transactions every day. Every transactions contain information such as payment amount, purchase location, purchase time, device information, and customer spending history. Over time, the bank collect large amount of historical transaction data. Some transactions are legitimate purchase made by customers. Others are confirmed fraud cases. This historical information is used to train a machine learning models. During training, the model studies patterns that commonly appear in fraudulent activity. For example, it may learn that purchase occurring in multiple countries within a short period of time can sometimes indicate suspicious behavior. It may also learn that unusual large purchases or unusual spending patterns can increase fraud risk. After training is complete, the model begins evaluating new transactions in real time. Whether a customers make a purchase, the model analyze the available information and estimate whether the transaction appear normal or suspicious. If the transaction seems suspicious, the bank may request additional verification or temporarily block the transaction until it can be reviewed. Now let's connect this to a model evaluation. Suppose the model incorrectly flagged many legitimate purchase as a fraud. Customers may become frustrated because their cards are being blocked unnecessarily. On the other hand, if the model misses actual fraud case, financial loss may occur. This may evaluation is so important. Organizations use evaluation metrics to balance security, customer satisfaction, and business performance. The goal is not simply to identify fraud. The goal is to identify fraud while minimizing inconvenience for legitimate customers. Let's move to the next slide. Next slides. At this point, model evaluation may sound straightforward. However, organizations often face several challenges while evaluating machine learning systems. One challenge is that testing information may not always represent real world condition. A model might perform well during testing but encounter different situation and once it is deployed. Business environment can also change over time. Customer behavior, market condition, and user preference may evolve. As these changes occurs, a model that once performed well may become less effective. Another challenge i- involve datasets that contain very few positive cases. For example, fraud detection systems may contain millions of normal transactions but only a small number of fraud cases. This makes evaluation more difficult because an important case are relatively rare. Poor quality information can also affect evaluation results if the testing information contain error, missing value, or inconsistency. Organization may not receive an accurate picture of model performance. Different department within an organization may also have different priorities. Security teams may want stricter fraud detection, while a customer service team may want fewer false alarms. Because of these challenges, organization does not evaluate model only once. They continuously monitor, review, and reevaluate machine learning system to ensure that they remain effective over time. Evaluation is an organization process rather than a one-time activity. Let's move to the next slides. So now let's discuss the benefit of effective model evaluation. At this point, we have learned that machine learning models must be tested before they are used in real world environments. But What advantage do organizations gain from spending time on evaluation? One major benefit is that evaluation help organization understand the strength and weakness of machine learning models. Instead of guessing how well model performance, organization can use re evaluation results to make decisions based on evidence. Evaluation also support better business decisions. When organizations understand the performance of a model, they can decide whether it is ready for deployment or whether additional important improvement are needed. Another important benefit is confidence. Business are more likely to trust more machine learning predictions when they know the model has been carefully tested and evaluated. Evaluation also help organization compare multiple model fairly. For example, a company may train several different models and then use evaluation results to determine which one perform best. Risk reduction is another important advantage. By identifying weakness before deployment. Organization can avoid costly mistakes and improve overall system reliability. Evaluation also encourage continuous improvement. Machine learning systems can be monitored and adjusted over time as new information become available and business requirement change. Ultimately, effective evaluation help organization create machine learning evaluation that are more accurate, reliable, and trustworthy. Let's move to the next slides. So before we conclude this presentation, let's quickly review the most important concept we discussed today. First, we learned that a model evaluation is process of testing a machine learning model after training has been completed. The purpose of evaluation is determine whether the model can make accurate and reliable predictions when working with information it has never seen before. Also, accuracy help us understand how often a model make correct predictions. Overall, precisions help measure how trustworthy positive predictions are. Recall help determine how effectively a model identify important positive cases. We also learned that there is no single evaluation matrix that works best for every project. Organizations choose evaluation method based on business goals, risk, and consequences of predictions error. Overall, model evaluation plays a critical role in helping organizations build reliable and trustworthy machine learning solutions. So that's it. This brings us the end of our presentation on model evaluation fundamentals. Today, we explored how organizations measure machine learning performance and determine whether a model is ready for real world use. We also learned about accuracy, precision, recall, and so how different industries use these metrics based on their specific goals and requirements. Understanding model evaluation is important because even in well-trained models must be tested before organization can trust its predictions. I hope this presentation helped explain these concepts in a single and easy to understand way and provide a better understanding of this organization evaluate machine learning systems. So my name is Akash Patel and this is presentation is a part of my AWS certified machine learning engineering learning journey at Concordia University, Chicago. I would like to express my sincere appreciation to my professor, Dr. Victor Govindaswamy, for his continuous guidance, encouragement, and support throughout this learning experience. So, thank you very much for watching this presentation and have a wonderful day.